In this video, we'll review air filters, filter housings, filter ratings, and how to use a VFD to maintain flow when filters get dirty. Most people spend the majority of their time indoors, so knowing all about filters is important for good air quality and health. This air handler has a differential pressure transmitter measuring the pressure drop across the filters. When the filters become dirty, there will be an increase in the pressure across the filters, which will cause a loss in flow, or CFM, if nothing is done to correct the problem. Here we use a variable frequency drive, VFD, to adjust the fan speed for any loss in pressure across the filters. When the differential pressure reaches a certain static pressure, the VFD will go into action and speed up the fan to compensate for the additional pressure drop created by the dirty filters. A set of contacts can be made that sends an email alert to the facility engineer to notify them of the dirty filters. Filter housings provide an enclosure for the filters and can be installed indoors or outdoors in new systems or used for a retrofit project. Here's a filter housing manufactured by Camfil that can be used outdoors and has a 25-inch deep side access which accommodates a 2-inch or 4-inch deep pre-filter, one 2-inch or 4-inch deep intermediate particulate or carbon filter, and a 6-inch or 12-inch deep rigid or pocket final filter. V-shaped filter housings allow for additional filter area using this arrangement. Housing are available for pre-filters, final filters, HEPAs, and roll filter housings. We can easily retrofit this air handler with a filter housing. First, we cut into the main supply ductwork, then install some transitions that match the size of the housing connections. Then we install the filter housing and support legs. This filter housing has a pre-filter and final filter. The pre-filter catches the larger particles and protects the more expensive final filter. So some of the items we want to filter out, everything from human hair, which is in the visible zone, to pollen, to coarse dust, that's the larger particle sizes, cat dander, pet dander, fine dust, which is smaller particles, tobacco smoke, some is visible, some of the particles aren't, and then the SARS virus in respiratory droplets is about 1.0 micrometers, and then viruses 0.1 micrometer and smaller. So you're looking for a filter that's going to take out what it is you're looking to take out. Now, this shows ASHRAE's standard 52.2. There's 3 ranges of sizes. This is 0.3 to 1.0 micrometer, 1 to 3, and 3 to 10, the different sizes of microns. As you can see, the MERV rating here, these filters in the beginning here don't take out much on the smaller particle sizes and not that great on the larger particle sizes. So you really want to stay in the MERV 11 and higher rating. And we've reduced the chart to 11 and greater. And you can see on the small particles, 0.3 to 1, the MERV 11, 12, and 13 is 50% and under efficiency. So if you move to a 14, you're going to get 75%. And as you can see on the larger particles, all the filters do better. It's a little easier to catch a large particle than it is a very small one. So you can see the MERV 16s is rating 95 in all size ranges. So of course that's a more expensive filter, but you might want to stay at MERV 14 if possible, or a 13. It's depending on what particles you're trying to capture. If it's all large particles, then basically any one of these filters is going to be pretty good. How filters work. There are 4 basic methods by which dust and particles are captured by the air filter media. Straining occurs when the dust or particle is larger than the gap between filter fibers. This is one of the common methods of removal in low efficiency filters. Impingement occurs when a large, dense particle collides with the filter fibers directly, not being able to follow the airflow around the fiber. The fibers can be coated with an adhesive to assist in retaining the particle. This is also one of the common methods of removal in low efficiency filters. Interception occurs when the dust or particle rides the airstream through the filter media and at some point leaves the airstream and attaches to the media fibers. This method is used for particle removal in medium efficiency filters. Diffusion occurs when very small particles are influenced by air molecules, colliding with them, causing them to move erratically through the airstream. This allows the small particles to become attached to the filter media, which is a method used in high efficiency filters. Electrostatic occurs when particles are given the opposite electrical charge as that of the filter. The particle would then be attracted to the filter when passing through it. If you like that video, please give it a thumbs up and subscribe to our channel. Thank you.